Hello everyone, welcome to the class of programming with Python. All this while in the preceding classes we had learned different concepts like data types, decision making, operators, etc. This session particularly focuses on loops. So if you were to understand what a loop is, let's first try to understand how the flow of Python is basically. So since you know that when you code in Python, you basically write a lot many instructions, isn't it? You would write an instruction here, here, line by line, you would keep writing the instructions. And when you run the Python, you expect that machine should be coming from top to bottom, reading your each instruction and following it. So machine would have followed your first instruction, then it would have come to second instruction, it would have followed. Similarly, it would have come to third instruction, it would have followed, and top to bottom, once all the instructions are followed, then your program would stop, right? That's how we write. If you were to see here, for example, I would say print hello class. So this is my first instruction. The second instruction I would write print I hope everything is wonderful. Yeah, this is the second instruction. If I run this, you would see that first the hello class is printed. That means my first instruction is run by the Python, and then the second instruction is run. I hope everything is wonderful, right? However, there might be a time when you might want to run, or you might want to do a certain instruction, or you might want to uh, follow one particular instruction for more number of times. To give you an example, what if I ask you to print your name 5 times? Then what would you do? I would perhaps write print Arun Kumar, and I would write that again, print Arun Kumar. I would write that again, Arun Kumar, print Arun Kumar, and I would write that 5 times, right? So if I were to print my name, if I want my name to be printed on the screen for the 5 times, I would write an instruction in the Python language to print my name on the screen for 5 times. And when I run this, you would see that it is honored, correct? It's being printed on the screen. But what if I want to do so this is a single instruction basically, right? It's a single instruction which you are repeating. You're repeating for 5 times because you want that particular instruction, the output to happen for 5 times. But what if I told you that I want that 100 times or 10,000 times or 200 times? Do you really think that it is practically possible to keep on writing this instruction for 10,000 number of times or 100 number of times or 20,000 times? No, right? It's not practical. We cannot be writing that instruction for that amount of time. And that's where the concept of loops comes into picture. So how the loop works is basically, in the normal scenario, your Python is coming from top to bottom, executing all the instructions that are falling on its way. However, when there is a concept of loop being implemented, then what happens is Python keeps on executing that same instruction. So if there is a same instruction, it keeps on running that for n number of times. Okay, for n number of times we'll keep on running the same instruction, and when it is done, then it shall move on, right? So if I have to print my names 100 times, then it would keep on printing for 100 times, and then it will move on to the further instruction. But how do we do that? How does the concept of loop works? Before we understand the concept of loop, how loop works, we should know what a meaning of loop is. Loop is nothing but, even in a literal terms, it is meant by it means something like iteration or round and round, isn't it? Which is an analogous to keep on doing something uh, time and again. So in Python there are two concepts basically, two keywords. One is called as while, the second one is for. So basically you are going to have two instructions. I mean, two keywords. One is while loop, second is for loop. We are going to learn both of them shortly, and you will see that how they are utilized in Python. So you have two loops. So, so let's see how we can use the. Let's first learn what a while loop is. Okay. Like I said, if I want to print my name 100 times, then what I'm going to do is, let's first learn what is the syntax of while loop. Just like we had a syntax for decision making, like if condition colon body or else body, in a similar way you also have the syntax for while loop. I'm going to write while condition colon body. Okay, it's all same. You write for the decision making, your keywords are if and else. However, for the while loop you have the keyword as while followed by condition and then body. What this means is, while your condition is true, while your condition is true, you're continuously going to keep executing whatever is written in body in this particular section. Okay, this could be a one line code, or it could be multiple line of code. Instruction 1, instruction 2, instruction 3. Okay, now what is this while condition? Try to understand that in just like a normal English. Every day in our day-to-day life we have so many situations when we say while you still feel hungry, keep on eating. While it is raining, do not go out. uh, while there is a power, keep charging your gadgets. Right, so many times we use while keyword in our day-to-day life. In a similar context we should be using while uh, when it comes to implementing the loop concept. What this means to Python is, or to a machine is, while the condition is true, I mean, here you're going to establish some condition. I'll show you shortly how to establish a condition. While this condition is going to be true, you're continuously going to run this and then move forward. Okay, so let me write here. mm, Let me say count equals to 0. Okay, so count is a variable which I am initializing by 0. Okay, here I'm going to write while count is less than 100, right? Because I said that I want to print my name 100 times. So here I'm going to write print, right? And here I'm going to increase the count value. What's happening here is, if you clearly observe, at the beginning I'm initializing my count variable to 0, and then I'm establishing a condition here. While count is less than 100, keep running this. What's happening here is, if this condition is true, then Python will enter into this body. First it will print Arun Kumar, and then it will increase the value of count. Why would it increase the value of count? Because if I do not, okay, let me first run this program and show you what the output is. You can see that my name is printed 100 times. If you want to see the value of count, let me also print this, both of them side by side. And if I run this again, you can see that 0, 1, 2, 3 all the way down up to 99. Now why 99? Because it's starting at 0. Yeah, and I'm saying while it is less than 100. Yeah? What just happened is, at the beginning the value of count is 0, and then my Python came here. It assessed whether the count value is less than 100. Of course it's less than 100, it's true. And because the condition is true, the Python entered inside this, it printed this, and then it increased the value. This is very important to increase the value, because if I do not write this particular line of code, it is going to forever be true. If I run this, you see it's forever is true, and it will continuously be printing. My Python has gone into an infinite loop, which is very troublesome. It will hang my computer. If I need to restart the kernel, okay. I cannot, as a software engineer, you cannot afford to have an infinite loop running, because if you go into infinite loop, the loop which is never getting false, or the loop which is never stopping, then you will continuously keep on running that. What will happen is you will run out of memory, and your program will either crash or your computer will hang. So at one point you should establish the loop such a way that at one point this condition definitely fails. How do I ensure that? I am continuously going to increase this, because I know that in the first loop this is going to be 0. In the second loop, 1 2 3 4, it is continuously increasing. There will be a time when this will reach beyond 100. At that time this will become false, and then onwards it will stop entering into this and it will move forward, it will move on. So let me write here, I am at the end of program. Okay, here I'm going to write print I am about to enter into the loop. All right, if I run this, you see Python had traversing from top to bottom. It executed this first, I am about to enter into the loop, and then it started continuously looping around here, iterating around these set of instructions, and it was printing 0 Arun Kumar, all this. And at the end, when the condition became true, when this condition became false, I aborted executing this and I reached here. You can see that I'm at the end of the program, right? So basically what happened is something here, what you see here. So I was coming from top to bottom, and then I came across a while concept. This is where the point my condition was located. I would check whether my condition is true. If while my condition is true, as long as my condition is true, I am going to go around all the instructions that are written within the condition. Something like this. This is the first instruction. This is the second instruction, and I'll keep on executing them, and I'll come back to the same point. Yeah, something like this. After running all these instructions, I'll come back to my condition here, and I'll check whether is it still true. If it is still true, I am again going to go around it and run all the instruction, and come back here, again assess whether it is still true. If it is still true, keep on executing. Yeah, and at one point when this condition becomes false, suppose this is false now, that point itself I am going to move on forward. Okay, that is how the loop works. I would like you to give this image a quick look. So basically our Python is coming from top, it encounters this condition. Okay, and when it is checking that condition, if it is true, then it is going to take this particular path, and it is going to execute the statement whichever we have written under the loop, and it is going to go back to the condition. If it is still true, it is again going to come back, it is going to keep running on this particular path, but the moment condition is false, it is going to take this false path. All right, so this is the pictorial depiction of how the while loop works in Python. Now, since we have learned how to write or implement a while loop, let's try out some hands-on coding practice utilizing the while loop. So my first Python program that I'm going to write to utilize the while loop is going to be write a program to print numbers from 1 to 10 using while loop. Okay, if this is my question, Let me write the code for it. So how would we do? So let me create a variable, say data equals to, or maybe I'll write number equal to 1, because I say 1 to 10, right? Or if I say 5 to 20, then I'm going to initialize it at 5 because this is the initial value. Now I'm going to write while number less than 21, okay? Or I can say less than or equal to 20, right? So this is basically collectively my condition. All right, I'm going to write print number, and then I'm going to increase the number. Here, if you observe here, I initialize it 5. I establish a condition that while it is still less than 20, less than or equal to 20, keep printing the number and then increase the number. So it printed 5, it got incremented to 6, and then it was again checked whether it is still less than 20. Yes, it again entered, and this is how I ended up printing 5 to 20. What if I, okay, this is the one program. What if I have to modify the problem statement, and I had to tell you that print from 20 to 5. Okay, so what's happening here is I am reversing, right? I'm coming from top to bottom, isn't it? Let's see how we can write a program for this. I'm again going to write a variable here. Initialize this time with 20 because I'm coming from top to bottom, reverse, isn't it? This time I'll say while number is greater than or equal to 0. I hope not 0, 5. Yeah. Why this? Because I'm coming from top to bottom. I know that the way I would run a loop, I'm going to keep on decrementing the number from 19. From 20 I'm gonna come down to 19 to 18 to 17 to 16 to 15, all the way down to 5, because I have been told to print from 20 to 5, isn't it? So I should ensure that it is greater than or equal to 5, and here I'm going to write print number, and here I'm going to write number equal to number plus, oh sorry, number minus 1. Please note that this time I am decrementing the number. Why? Because I know that I started big. I started at 20, and if I have to keep coming down, I need to decrement it. So if I run this code, you will see that I have been able to print 20, 19, 18, 17, 16, right? This is how it is. Let's consider now another program to practice our while loop. One thing you should remember is, if I'm writing this keyword and the condition which I'm writing here, and here comes the body, remember this condition, whatever we establish is going to be assessed for whether it is true or false. So basically, if I write say 5 less than 3, this is always going to be false, isn't it? Because 5 is not less than 3. But if I write 5 less than 10, then it is always going to be true. So this is like a permanent true, because while my program is running, 5 less than 10 will always be true, and this I will enter into a infinite loop, never going to come out, keep on running there, I'm going to get stuck. The other way to write this is I can directly, end of the day, what's happening? The condition is getting assessed to either the value true or to the boolean value false, right? So when ultimately this is going to get assessed to a true or false value, I can myself write true here, right? This approach can also be taken in the event when you want infinite loop to happen. So let's look at some real life examples. When would you like to directly write or directly make the condition true? Okay, uh, I'm pretty sure you all would be using the Netflix or the Instagram or any other social media platform like Gmail, wherein you would be entering the user ID and the password, isn't it? Now what these platforms do is they keep on asking you to enter the password until the time you enter the correct password, right? So let me say password in database underscore db in databases user 1122. This is the password that is stored in my system. I am going to ask user now here. Okay, this is not equal to, but before I read, let me ask user to provide the input right then and there. Okay, so I'm checking if this is not equal to, then I will keep on asking user to enter this. What's happening here is I have a password stored in my system. I'm asking user to provide a password, and then I'm checking whether the password that is stored in the system, if it is not equal to, as long as these two passwords are not matching, I'm going to keep printing the password you entered is not correct, please retry, and I'm going to again take the password from the user. Okay, and here I write, okay. So this is how, if the software engineers are developing the mobile platforms, or the system platforms like Netflix or Instagram, how do they verify? They have something that is already stored in the system. They keep on asking you to prompt, they give you the prompt to enter the password, and whatever password is entered here, this is how we're checking while it is not correct. As long as this is not correct, you will keep on be asking to keep on entering here. Now if I run this, there is a slight mistake here, line number 12. Let's see what. Yep, I missed the quote here. Okay. Okay, if I run this, you see it's asking me enter your password. I write here, maybe I write here 1 2 3 4 5. Yeah, this is of course wrong. If I enter here, what does it say? It says that the password you enter is not correct, please retry, and I'm again being prompted. I will again give the wrong password here, something like this. It And this becomes, I am into a endless loop. Look at this. I am stuck into this loop because I am repeatedly checking whether whatever password I have fetched from the user, it is not matching what is stored in system. But let me provide now what is stored in system, that is user 1122, right? This is as same as what is already stored. If I hit enter here, you will see that the loop is immediately terminated. Why? Because the condition became false, and this is the time when my Python, it do not enter into the while loop any further, and it directly enters, it moves on, it executes these lines of code which you see here, successfully logged in. Correct? Yep. So this is another example of the usage of while loop. There is another concept that is associated with the while loop that we should be focusing on right now, and that is, suppose your loop is running. If you're within the loop, and there might be a case when you suddenly want to stop looping around or stop iterating over those set of instruction. For example, in a daily life, if we are if you're working on something, we suddenly hear a sound and we stop working right then and there, and we go away and to address what the sound has come from. So what we did is, we were involved into doing something continuously, and then we suddenly aborted that particular operation, and then we moved away to do something else, isn't it? The same thing can also happen in the while loop. Suppose you are running a while loop, you are executing the instruction uh, for n number of times. In between, there might be a situation when you want to abort or stop the loop. Then how do you do it? Suppose I have, say, count equal to 0, and I'm saying that while count is less than 20, print the value of count is, and here I'm going to write count equals to count plus 1, and here I'm going to write print I am outside the loop. At the moment, it's a normal program. Obviously, after 20 times the count is printed, I will naturally be done with the loop and I will come out, right? Look at this. But what if I want to suddenly come out of the loop? For example, I want to come out of the loop, say, if my computer or my software detects that, oh, this is a count 10, then if it is 10, then I want to come out. I want to come out of the loop right then and there. And what I can do is, I will make a decision here. I already taught you in the previous class how a decision is put in place. So I will use if. I will check if count is equal to 10. That means I'm checking if this condition is true. If this condition is true, remember I will write this keyword break. Please remember, the moment Python encounters break, this break keyword can only be used within the loop concept. The moment Python encounters break, it immediately comes out of the loop. It's going to come out of the loop and it's going to print I'm outside the loop here. You see? So although my condition was up to 20, the moment it is it encountered break. Obviously, it will encounter break once the count reaches 10. It has encountered the keyword break and it aborted. It immediately left the loop and it moved on to the further instruction. That is here you see, right? It is not going to care whether there are any further instruction left to be executed or not, or whether the condition is still true. No, the moment it says break, it's going to break off from the process of loop, right? The next thing I can tell you is the break. What break does is it immediately breaks off from the loop. But suppose if I arrange my instruction like this, okay, so the way I have arranged my instruction is, first it is going to continue looping around. It is the moment it enters here inside the loop, it is going to increment it, and then it checks if it is 10, then it's going to break off. If nothing, then it's going to print here the value of count. But what if I want to skip executing these instruction for that particular loop? For example, at the beginning I'll come into the loop number 1, then loop number 2, loop number 3. Every time I'm entering into the loop, I am running these amount of instruction, right? From top to bottom, these instruction I'm running. But we have something called as continue. Okay, if I put this continue in keyword here, what happens is, the moment Python encounters this continue, any pending instruction for that particular loop will be ignored. Okay, so Python will skip executing any pending instruction for that loop and it will move on. It will reach back to the next loop. So if I am at the say 10th loop, I am yet to print the count 10, right? I will not print it. I'll skip and I'll move on to the next one. So if I run this, you will see that there is a slight indentation. Remember, I have to align it all equally. Yeah. So you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th one is skipped, right? So 10th is skipped and I continued from the next loop onwards. If I have to show you better in a more pictorial way, then I would tell you that Python is coming now normally here top to bottom. I am running the instruction like this repeatedly. If I encounter break, say suddenly I encounter break, then what happens? Then and there I ignore the process of the loop and I move forward. Python moves forward. Okay. However, if I am say if I am running my loop normally, and at one point I encounter the continue keyword, then what happens is I am not going to run pending instruction for that loop. I'm going to restart from the beginning for the next loop onwards. Okay, so this is how it works. We have covered already a few of the examples which demonstrates the concepts of while loop. Now let's see how else a while loop can be used. For example, if I have a variable called as cities, okay, now let me create a list. So this is a cities variable which is containing list. For example, I have Tokyo here and I have New York here, Mumbai, California, Toronto, Moscow, okay, and Paris. These are some cities. All these are individual elements are string data. Since I have a collection of string, that's why I am storing them all in a list. And as you would have remembered from the previous class, if I have to print or access the whole city, I'm going to write the whole name and I'm going to run it. If I have to access only the one element, then I'm going to write a square bracket. Remember, it's a square bracket. If it's a function, you always write a curved bracket like print or input or sum or length. All these are function calls. You're triggering a function. I'll tell you in the later class what a function call is, but when you call a function, you write a curved parenthesis. However, when it is time to access certain data partially or very specifically, then you write square bracket very next to that variable. If I write 0 here, that means I am accessing the 0th position. I hope you all remember that when the list is accessed from the left to right, then the positions are positively numbered, which starts at 0 and goes on positively numbered like this, so on and so forth. Okay. However, when you are coming from right to left from the other direction, then your positions are numbered with minus sign. Minus sign indicates that it is negative position that you have considered, and this is how you it is numbered. So on and so forth. Okay. Let me comment this out, otherwise it's going to give an error. Okay. If I'm giving here 0, that means obviously I am trying to access considering the positive scale going left to right. So 0 will indicate Tokyo. So if I run this, you will see that Tokyo is being printed. But if I give -2, Moscow shall be fetched for you. If I tell you that I want to print all these, if I tell you that I want to print all of these cities one by one, then how you're going to do? You're going to write something like this, isn't it? Print cities 0, position 0, position 1, position 2, position 3, and so on and so forth. So one by one you will have to write, but accessing all the elements in a list like this one by one, it's not a feasible way or it's not a practical way, because tomorrow if I give you a list with 10,000 elements or 1 million elements, you cannot sit and write uh, these codes one by one to access each element. No, that is not a practical way, right? Then how can you do that? If you observe here carefully, basically the instruction is same. The whole instruction is same. The only thing that is changing is the data within it. So the good way here is, let's try to use the concept of loop. Since the instruction is same, I am going to run that for n number of times. For example, I'm going to write, say, position. Okay. This is a variable I'm creating. I'm initializing at 0 because I want to start at 0th position. Now what I'll do is, while position is less than 0, 1, 2, 3, 4, 5, 6. Okay, I'll write 7, less than 7, because I know that it can go up to 6. 0th position, first, 2, 3. Okay, now I'm going to write print position, and I'm going to increase the position here. If you observe carefully, what's happening is, while position is less than 7, I'm going to print city's position. So as we know that position is initialized at 0, so in the first loop this shall be 0. Okay, and then it will print, because it is 0, as the position variable is holding 0, so I will be printing Tokyo here. But once this is executed, then I'll come down here where I'm incrementing the position. So now position has changed from 0 to 1. In the next loop, I check if 1 is less than 7. Yeah, because position is holding 1. This is again true. So if it is still true, it is, I'm going to again come down and I'm going to print city's position. This time position happens to be 1. So I'll end up fetching New York. So if I run this, you will see that now this is like a generic code. I utilized the concept of while loop to run same instruction certain number of times. Certain number of times as in 6 number of times. Remember, I cannot write it 10 here, because if I write 10 here, but my positions are limited, my positions are only up to 6, 0, 0 to 6. If I write a condition which is going beyond 6, then it will give me an error, because my Python will try to access 7th position or 8th position or 9th position, which do not even exist. So this will give me index error. You can see that after a certain time it gives me list is out of range. I am trying to access something out of range, right? So I have to be very mindful that what condition I am establishing here. Okay, I have to be very mindful that my position should not cross the it should not cross the value which is beyond this limit. If you think that list is very long, it can be millions of numbers or billions or thousands, which you think you cannot count, just how I counted 7, then what you can do is you can write the length function. What length function does is it counts the length of elements. So I can push cities in this. It doesn't give me the hassle to create and write number here. So now I can increase more element here and my Python will adjust here. Okay, something like this. If I run this, you see it's all running fine. Suppose I had to come reverse in this direction. Yeah, if I had to come reverse, then what I will do is, what is this position? Remember, since it is starting at 0, that means if the length is 7, then the last position is 6. It is 1 less than the total length because it starts at 0. So here I can write, so if this series, if I had to print in the reverse order, what I'm going to do is I'm going to write, I'm going to initialize the position to something at the last. So whatever the length is, that is 7 less than 1, that is 6. So I have positioned this particular value here. I'm going to check whether it is greater than or equal to 0, because I know that the least position here is 0. Okay, and here I'm going to write -1. So I've controlled this variable that it should come from the last position to this position, and this instruction will fetch me the whole list in the reverse order, right? Okay, you can not only use this while loop just to access these elements in these orders, but you can also take decisions. For example, let's consider another example here. Here I am writing student marks. Okay, I created one variable where I have stored student marks like 83, 85, 63, 45, 23, 36 and 98. So there are 6 subjects. I've created 6 marks. If someone tells you, I need to know in how many subject did student fail. If I were a human, how would I act? I would walk through each marks, and of course, let me tell you that the passing marks is 40. Okay. If I have to tell me how many subjects did the student fail in. You will start walking from left to right like this. You will assess each element and see how many subjects are less than 40, isn't it? Let's see how we can do the same task through Python. See, end of the day, this Python is making the machine work, and machine are somewhere working like a humans. So the way we would work, we would walk on each element, assess if it's pass or fail, and then tell the count. So let's first say, first create a variable, failure counts. Okay, this is 0 because I am presuming that student did not fail. Now I am going to check position is equal to 0, and I'll write while position is less than length of student marks. I'm going to check here if student mark, in bracket I'll write position because this is fetching me that corresponding marks. If it is less than passing marks, so here I am taking a decision. I am walking through, because using the while loop I am walking through each element. Here I am taking the decision. Here I'll increase the count. If I encounter that if this condition is true, that means student is failing, I will increase this count. And I will also ensure that this position is increased, because otherwise it will be an infinite loop. Please remember, this failure count is a part of if. That is why it is further indented. Okay. However, increasing the position is at the same level as if. It has to be outside the if block. So this is how I will be writing my code, and after this I'll be printing my result here. So once my loop is done, I know that I have walked through each score, I have assessed each score towards whether it's a failing or whether it's passing, and that's how I have recorded all my results into the failure counts. Now my output will be presented as the total subjects in which student failed is failure counts. Look at this, it's two subject, right? If I change the data here, say this 45, let me make this 85 as 10, and if I run this again, it says it's 3. You see, now I can establish, I can feed 50 students data or 100 students data this piece of code or logic, wherein my decision making, my loops, my list, different concepts of Python are working in sync to produce a program. A program is nothing but a set of instruction. This set of instruction has developed an application that is going to check or count how many subjects did the student fail, and it is going to give you the overall results. So this is how we program. I'll be giving you the quiz as well as the assignment for this particular session. I would request that all of you please practice it to enhance your hands-on and better understanding of this particular concept. If you think you have any doubts, just reach out to me individually. I'll explain you one to one. Yep. Thank you.